I really do not know why it is very difficult for students to do qualitative analysis successfully. It's actually not really difficult. Hello, good afternoon. I'm going to be explaining from the scratch how you attempt the WAEC practical, WAEC qualitative analysis practical. Okay, so you're welcome once again. I'm the educator mom, a full-fledged scientist. So I've observed over time that students have difficulty in identifying sorts or in the way they record it. As I usually tell my students, one of the best ways to understand how these things works is for you to understand the theoretical backing. Alright, you must have a mindset of what type of salt it is by the color of the salts. So here is the table of the appearance of salts. So you check it out. You can pause the video and check it out. So one after the other, let's look at what these salts, how their colors are. So the white salts are usually lead salts, zinc salts, aluminum salts, calcium salts, sodium, potassium, and sodium salts. When you see all those salts that are white, those are the suspicion based on WAEC. I'm not saying that those are the only salts that are white in chemistry. No, strictly WAEC. Now, when you talk about the ones that have color, let's see. Blue is usually copper. Reddish brown is usually iron 3. But note that at times iron 2 can be reddish brown because I have iron 2 here that is reddish brown. Then green can be iron 2 and it can also be copper. You have been able to have a hint when it comes to the color, then you just have it in mind that, oh, if it is blue, you begin to eliminate the one that it cannot be. So the next other thing that you can do to identify is the flame test. We are not going to carry out the flame test, but when you attach a particular solid, which is metal, onto maybe a deflagrating spoon or a wire loop, and you insert it into fire, then you are carrying out a flame test using a Bunsen burner. So if the color is brick red, then it is calcium. If it is deep green is copper 2 ion, lilac is potassium ion, golden yellow is sodium ion, blue flame is lead 2 ion. So if the examiner wants you to carry out flame test, use this color code to identify the ions. So now let's go right into testing for these things. Okay, before we continue, I told you that the ions that are white are calcium. They are calcium ion, aluminum ion, zinc ion, and lead ion. There are two reagents that we use for qualitative analysis to test for cation in WAEC, preliminary test. So we have sodium hydroxide solution, and ammonium solution. So you must have a base knowledge of how this thing works before you even go into practical. If you're using sodium hydroxide and you get a white gelatinous precipitate, it can only be zinc and aluminum, that's Zn2 plus or aluminum 3 plus. And if it is a powdery precipitate, it can only be Ca2 plus or Pb2 plus. So do not mix it up. Don't just say white precipitate and line up all the 4 ions. White will not mark it. You have to be specific. Alright? So how do you know if it's powdery? Just like when you put powder inside water, that very white nature is chalky or powdery. But when it looks a little light, like transparent or jelly-like, at times jelly nature will come out very well, then that's gelatinous. So you must have this base knowledge before you even try to do your practical at all. So that's in drops, it tells you the color of the precipitate, the color and nature of the precipitate. Then in excess tells you if the precipitate is soluble. Note, whenever you put in drops, it gives you the color of the precipitate. Whenever you put in excess, you are supposed to report on the solubility of the precipitate. Now, in drops, if you put a reagent and it gives you a white gelatinous precipitate, your observation should be white gelatinous precipitate is formed, and your inference should be Zn2 plus or Al2 plus. That's in sodium hydroxide. And sodium hydroxide in excess, both of them will dissolve. We will write precipitate dissolves or precipitate is soluble. That still remain aluminum 3 plus or Zn2 plus. That means that sodium hydroxide cannot be used to distinguish between aluminum or zinc. So now let's go to calcium and lead. It also gives you a white chalky precipitate on addition of sodium hydroxide in drops. In excess, lead will dissolve, calcium will not dissolve. Sodium hydroxide can be used to distinguish between lead and calcium, right? So now, Talking about ammonia, when you put ammonia solution in drops and you get a white gelatinous precipitate, your inference will be Zn2 plus or Al3 plus. Then in excess, if it dissolves, it is Zn2 plus. If it does not, then it's Al3 plus. Also, when you put ammonia solution and you do not get any precipitate, you are suspecting calcium, because calcium has no precipitate when ammonia is added. Okay, and you have a white chalky precipitate on addition of ammonia solution to lead. In excess, it will not dissolve. Okay, in excess, it will not dissolve. All right, so let's get right into it. Talking about the ones with color, they are very straightforward. Copper will give you a blue gelatinous precipitate. Iron 2 will give you a dirty green gelatinous precipitate. Iron 3 will give you a reddish brown gelatinous precipitate. Those are the common ones. Though we have chromium, which gives you a light gelatinous precipitate. And all of them, both in sodium hydroxide and both in sodium hydroxide and in ammonia, they are usually insoluble except for copper. Copper in ammonia will dissolve to give a deep blue solution. But when it comes to iron 2, iron 3, they give their gelatinous precipitate, and in excess they remain insoluble in both sodium hydroxide and in ammonia solution. When you add water, what you're supposed to look out for is solubility. What you're supposed to look out for majorly is solubility in most cases. So you should also go and learn your solubility table. If you need help on that, you can comment below. So these are the white salts that I want to test. Okay. So I'm going to be using this as an example. So the first one, this sodium hydroxide. See what I'm saying? This is a white gelatinous precipitate. A white gelatin. You can see how it is. Look, not so white, sticky. A white gelatinous precipitate. So this is what? Either Zn2 plus or Al2 plus. So in excess. See, it's clearing up. At times, it does not go immediately, but if you know what you're doing, you'll be patient with it. And that thing you can see in solution. Still on the first one, if I put ammonia solution, this is still a white gelatinous precipitate. Then excess ammonia. You see it's clearing up. Once you put it, there's a reason why they said excess. You begin to shake it. So, as you can see, it has dissolved. So that is telling us that this is zinc. It is soluble in excess sodium hydroxide, also soluble in excess ammonia. Let's check the second one. So this is aluminum solution. Aluminium. Sodium hydroxide. In drops, gelatinous. In excess, soluble. You see? So this is aluminium. In drops, gelatinous. In excess, you see, it became more cloudy it did not dissolve. No matter how much you shake it will not dissolve, and it will go. You will see it will settle. Instead of clearing up, it will become thick and settle. That's how to know that something does not dissolve. So this is aluminum. It does not dissolve in ammonia, but zinc does. Now let's go to the powdery ones. This is a lead solution. You see? Very different. Can you see? This one is white. Can you see? White. It's different from that one that was jelly-like. Look at it. Powdery. 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 Okay? So, in excess ammonia, does not dissolve. So, in drops and in excess, lead salt does not dissolve in ammonia. You see? Lead salt. Look at it. Does not dissolve. Does not dissolve. So let's test that lead using sodium hydroxide. In drop, still a white chalky precipitate. In essence, can you see? Dissolves. So that is lead 2 ion. Now the last one of the white. This is calcium. Calcium in sodium hydroxide. A white chalky precipitate just like that. In excess, can you see? Does not dissolve. That is a typical property of calcium. A white chalky precipitate is observed. The precipitate is insoluble in excess. Now, in ammonia, if it is calcium, no precipitate. It gives no precipitate in ammonia. Okay? No precipitate in ammonia. That's to show you that it's calcium. You can see if you do all these things very well, you have no business, as in you will have no issues. Know what the answers are before, then when you test it, it fits in. So now, these are the transition metal salts. Let's test them. Let's go with this first. Sodium hydroxide. This is reddish brown gelatinous precipitate. See the gel. Reddish brown gelatinous precipitate, that's iron 3+. In excess, it does not dissolve. Precipitate does not dissolve. That's iron 3+. Let's test it with ammonia. That's a solution with ammonia. Reddish brown gelatinous precipitate. In excess, the precipitate does not dissolve. Okay, that's iron 2. Iron 2, whether in sodium hydroxide or in ammonia, the report is the same. Reddish brown gelatinous precipitate, insoluble in excess ammonia, insoluble in excess sodium hydroxide. I told you that some iron 2 can also be reddish brown in terms of color, but how we distinguish it is when we test it. So this solution is supposed to be iron 2, and if it's iron 2, it's supposed to give us in sodium hydroxide, you see, a dirty green. This is like army green. They call it dirty green gelatinous precipitate. In excess sodium hydroxide, it does not dissolve. Let's try it with ammonia. a dirty green gelatinous precipitate, insoluble in excess. So now let's go to the last one, which is copper. Sodium hydroxide, blue gelatinous precipitate.
Somebody's cooking. She's cooking.
What's up? How was your exam? Precipitate does not dissolve. That's copper 2 ion. Let's try it with ammonia. So still pale blue gelatinous precipitate. Then in excess, it dissolves to give a deep blue solution. It dissolves to give what? A deep blue solution. So, if you have any question, don't hesitate to ask me. Alright? Thank you. Don't forget to like me. There are still more WAEC series coming. Thank you. Bye.